With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question it is given that there is a kid of height 1.1 feet which is sleeping straight between focus and the center of curvature along the principal axis of a concave mirror of a small aperture. Now his head is toward the mirror and 0.5 feet from the focus of the mirror. How a plane mirror should be placed so that the image formed by it due to the reflected light from the this concave mirror looks like a person of height 5.5 feet is standing vertically. We need to draw the ray diagram and also need to find the focal length of the mirror. So first of all, we just represent our situation. Let's say this is our situation. We are having a concave mirror. Likewise here. Okay. Let's say this is our focus. And this would be our this center of curvature. So this is our C, this is our F. Now our object is lying here. That means the kid is lying here. Let's say this end, which is his head, is B, and this end, which is his leg, is A. Okay, we can just represent it. Now what we can see that this end is closer to the mirror, okay, to our concave mirror. So this would be made at a farther location. Okay, we will be just drawing the ray diagram afterwards. So first of all, we just write, and this end is farther from the mirror, so it would be after refraction, it would be reflection, it would be closer to the we can say that closer to our this mirror. Now this is the situation. So this is the image location. So we say that this is the image for A and this is the image for B. Okay. Now here we have placed a mirror. Somewhere here we have placed the mirror. Now finally what is happening? Finally, let's say this angle is theta. This angle is theta. This is our mirror. We just make this surface to be the polished one. Now finally what is happening that this image, which is the image of the kid, it is becoming like this. Vertical. It is becoming like this. Okay. Now that means this is our A double dash and this B double dash, and B is basically same. We need to find what should be this angle. Now we know that if we just extend this line, okay, how can we get the value this location of the image? We can say that if we drop a perpendicular, okay, from this extension, we know that the distance of the object from the mirror, okay, so this is basically hypothetical mirror, would be same as the distance of image from the mirror. So this would also be same. This distance and this distance would be same. Now this is common. Okay, so we can say that this triangle and this triangle would be similar. That means if this angle, for example, if we just say that this angle would be vertically opposite angle, this angle is theta. Since these triangles are similar, so this angle would again be theta. So what is the total angle? So we can say that 2 theta would be equals to 2 theta. This would be equals to 90 degree. So we can say that our inclination would be equals to 45 degrees. Okay, so inclination would be equals to 45 degree. Now we just determine what is the focal length. Now first of all, we know that what are the various distances which have been given. Now this value has been given us to as 0.5. Distance from here to here is 0.5. So what is the distance of object from this our mirror? This distance, it would be focus. This would be focus plus 0.5. Now what is the distance of our object A from the mirror? So we say that what is this distance? It would be equals to, this is F, this is 0.5, and from here to here it is 1.1. So the total distance would be equals to F plus 1.6. So these are the distances of our objects. So we will be treating A and B, that means head and leg, as to be our objects. So if we apply our mirror formula, 1 by V plus 1 by U equals to 1 by F. This is the basic formula. So for first of all, we are just applying for B. That means our head. So we can say that 1 divided by V, we don't know where it is formed, plus 1 divided by U. Now U would be taken as to be negative because it would be measured opposite to the direction of incident ray. So we say that minus F plus 0.5. This would be equals to 1 divided by, now the focal length of the mirror, this concave mirror would be negative because it would be lying on the left. So it would be F. Now from this, we say that this is our VA. Sorry, VB, not VA, because we are determining for B. So we say that this is our VB. Now, if we just solve this one, so our VB would turn out to be, we can just take the LCM. So our VB, we can just take it to the other side, then our, and take the LCM. So VB would turn out to be minus F times F plus 0.5 divided by F. Okay, this would be the location of our, this B head. Now, similarly, if we do for A, again we apply the same formula, 1 divided by, but it would be for A, 1 divided by VA, then plus 1 divided by, because it would be A is also on the left side, so it would be F plus 1.6. This would be equals to 1 divided by minus F. Similarly, if we solve this, then our VA would turn out to be minus F times F plus 1.6 divided by 1.6. So this is 0.5. It would turn out to be, here in the denominator, it would be 0.5. Now, what is given? We have been given that the distance, this person height is 5.5 feet. Now, this height is given as to be 5.5 feet. So, we know that for the plane mirror, so whatever is the height of the image would be same as the height of the object. So, this height would again be 5.5. So, how can we get the value of the height, this 5.5? We say that the distance from here to here is the distance of the image, or we can say that VB. Now, the distance from here to here is the distance of our A, or distance of the image for A. So, we say that this from here to here, the value would be VA. Now, if we take the difference of these two quantities, we say that VB minus VA, and the mod of these values, this would give us the height as 5.5. Now, we apply the same logic. We will be taking 5.5. This would be equals to mod of VB minus mod of VA, because we need to just have the values for this part. So, this would turn out to be F. Then it would be F plus 1.6. Sorry, F plus 0.5, because VB is 0.5. So, it would be 0.5 divided by 0.5 minus F plus 1.6 divided by 1.6. Okay. Now, if we solve this, then it would be 5.5. This would be equals to 11 divided by 18. Sorry, 11 divided by 8 F square. Now, if we solve this, then F square would turn out to be 4. That means our focal length would be equals to what? It would be equals to 2. And this, the unit is feet. 2 feet would be the focal length. Now, we need to also draw the ray diagram for this part. So, we just draw, we are just representing for B itself. So, it would be similar for the A, okay? Because the situation would be same, because the rules which we would be using would be same. So, this is our focus and this is our center of curvature. So, we just represent here itself for the this B itself, okay? And for A, the case would be same. We just represent this is our B. Now, how can we do it? So, we draw one light ray, which is this normal. Okay, sorry, parallel to the principal axis. So, after reflection, it would be passing through the focus. Okay, this is one of the light ray. Now, from where we will be getting the second light ray? If we draw a light ray which is passing through the focus, now what will happen? After reflection, it would be becoming parallel. It would be becoming parallel like this. Okay, so wherever they intersect, this would be the location of our B. So, this would be our, we can say that B dash. Okay, similarly, we can draw for the for our A. So, hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.